Welcome to this explainer. We're going to take your Class 9 science notes on gravitation and turn them into a foolproof, dynamic study guide. If you're looking to master these concepts without getting bogged down in the fluff, you are in the exact right place. We're going straight to the core of what you actually need to know, locking this information into your memory so you're totally ready for test day.
Here's our game plan. We'll be navigating through 5 key areas: the universal pole, mass versus weight, thrust, pressure and buoyancy, Archimedes and relative density, and finally, exactly how to ace your science exam.
All right, starting off with Section 1, the universal pole, focusing on gravity and free fall.
So Isaac Newton proposed this foundational rule called the universal law of gravitation. And the core idea here is actually kind of mind-blowing, but super simple to remember. Literally, every single object out there attracts every other object. Seriously, your pen, the earth, the screen you're looking at right now, there's a constant mutual attraction happening between everything in the universe all the time. Now, for the exam, you need to know how that grand concept translates into math. Here is the formula you've got to know. F equals g times m1 times m2, all divided by r squared. Basically, force, that's the F, equals the gravitational constant, g, multiplied by your two masses, m1 and m2. Then you just divide that whole thing by the distance between them squared, which is the r squared. Definitely practice writing this one out because you're going to need it for your numericals.
Okay, so what happens if gravity is the absolute only force acting on something? Well, that brings us to free fall. Your notes specifically define free fall as the motion of an object when it is under the influence of gravity alone. No air resistance, no friction, just that pure, uninterrupted downward pull. And when something is in free fall near Earth, it accelerates at a very specific rate. That rate is 9.8 meters per second squared. We represent it with a lowercase g. Just lock this decimal into your brain right now, 9.8. It is the magic number you will be using constantly in your calculations.
Moving right along to Section 2, mass versus weight. This is an absolutely crucial exam distinction.
Honestly, this is the ultimate trap that examiners love to set for students. Here's the deal. Your mass is your foundation. It is constant, and it stays exactly the same no matter where you are in the universe. But your weight? That's calculated by taking your mass and multiplying it by g, the local gravity. So since gravity changes depending on where you are, your weight can totally change, even though your mass never ever does. Don't let them trick you on that. Okay, Section 3. Thrust, pressure, and buoyancy. The upward push. We're moving from the invisible forces pulling us down to the physical interactions pushing back up.
When a force, which is sometimes called thrust, is applied over a specific area, it creates pressure. The formula is beautifully straightforward. Pressure equals force divided by area. Oh, and a massive tip for test day. Your notes explicitly remind us that the SI unit for pressure is the Pascal. Make sure you remember that one.
But the physical world isn't just solid surfaces. The second an object is immersed in a liquid, it faces a whole new phenomenon called buoyancy. Your notes define this perfectly as the distinct upward force that a liquid exerts right back onto an immersed body. It's the exact reason things feel so much lighter when you lift them underwater, and it's how massive, incredibly heavy steel ships are able to float instead of plunging straight to the ocean floor.
Section 4, Archimedes and relative density. Let's look at the actual rules of the fluid.
To figure out exactly how strong that upward push is, we use a famous ancient rule called Archimedes' principle. It states that the upward buoyant force hitting an object is perfectly equal to the weight of the fluid that the immersed object pushes out of the way. Think of it as a one-to-one trade. The weight of the displaced fluid literally becomes the exact strength of the upward push. And to predict if a specific material is going to sink or float in these fluids, we use the relative density formula. It's a really simple comparison. You just take the density of your given substance and divide it by the density of water. It gives you the ultimate benchmark to understand exactly how the material will behave. All right, bringing it home with Section 5, Ace Your Science Exam. Time for some final tips and MCQs to give you that strategic edge. Let's lock in everything we've just learned. Based on your notes, what are the specific facts highlighted as totally critical for those tricky multiple choice questions? Here is your ultimate cheat sheet. First, the SI unit of pressure is the Pascal. Second, burn 9.8 meters per second squared into your mind for the acceleration due to gravity. And finally, always remember that Newton is the one who proposed gravitation. Spot any of these on the multiple choice section and you've got guaranteed points. Beyond just the quick facts, to ensure total mastery, your source specifically tells you to heavily practice 4 key areas before the exam. You need to drill your formulas until they're second nature. You must memorize your definitions word for word. You actually have to sit down and work through the numerical problems to prove you can apply the math. And whatever you do, do not skip practicing your diagrams. Visualizing these forces is totally half the battle.
I want to leave you with a provocative thought to really test your new understanding. We established earlier that your mass never, ever changes, but your weight relies entirely on the pull of gravity. So imagine you could travel to the exact core of our planet, where the gravitational pulls from all sides perfectly cancel each other out to zero. What exactly would your weight become at the very center of the Earth? Think about that formula, apply what we've covered today, and you are going to absolutely crush your science exam.